A capacitor is a device that stores charge. In order to see how this works, we start by looking at a simple battery. A battery you can think of as a device that maintains a high potential at one end and a constant lowered potential at the other. If we now connect two arbitrarily shaped conductors to either terminal, we find that at the interface between the battery terminal and the wire, at the instant we make the connection, there is a mismatch in the electric potential on the battery terminal and the electric potential in the wire. The instant we make the connection, the wire is still charge neutral, so the electric potential everywhere inside it has to be zero, while the battery, by definition, has a constant high potential at its positive terminal. Furthermore, we know that the electric field depends on the change of the electric potential with some spatial coordinate. Therefore, at the interface between the wire and the electric terminal, where we have a very large abrupt change in the electric potential, we can expect a large electric field pointing into the wire. By exactly the same arguments, we can expect a large electric field pointing into the battery at the negative terminal. The system will now try to reach equilibrium by eliminating this mismatch in potential between the wires and the battery terminals. To see why this happens, think about mobile charge carriers in the wires. We know mobile charges in the vicinity of a non-zero electric field like to move either parallel or antiparallel to the electric field. Specifically, if you look at negative charges, mobile negative charges in the wires will be pulled towards the positive terminal, while at the negative terminal, negative mobile charges will be pushed into the wires. Therefore, in an attempt to reach equilibrium, the conductor connected to the positive terminal of the battery becomes progressively more positively charged, while the conductor connected to the negative terminal of the battery becomes more negatively charged. What happens when equilibrium is reached? We know that we expect that positive charge builds up on the one conductor while negative charge builds up on the other. We know in electrostatic equilibrium that the electric potential everywhere inside a conductor needs to be the same. Therefore, in electrostatic equilibrium, the electric potential in the wire and the conductor connected to the positive terminal of the battery must be at the same electric potential as the positive terminal of the battery itself. And the same goes for the conductor that is connected to the negative terminal of the battery. This implies that an electric field is now set up between the positively charged conductor and the negatively charged conductor. Note that because the charge carriers are still in some way bound to these conductors, they are not free to jump the gap between the positively charged conductor and the negatively charged conductor. If we now remove the battery from the circuit, we end up with a device that effectively stores a certain amount of charge Q.